Alright, so here I am, I'm back at the grinding wheel. I found a good drill bit. It's about a 1/2 inch diameter. I got my sharpening gauge, and now I have on my face shield. Do yourself a favor, go to the eye washing station, spray the lens of the face shield with the cleaner, wipe it down, start with a good, clean face shield. This is a complicated process, and it's not going to be any easier if you can't see. Now, I do encourage my students to start off with a drill bit that's close to being correct. Now, it's a lot easier to take a drill bit that is just worn out and resharpen it than it is to take a drill bit that someone else has ground and made a significant error and then given up and put down. So do yourself a favor, and when you're digging through our little box of the drill bits for practicing on the grinder, find one that actually looks like it's pretty good. And the way you're going to be doing that is first, just a quick visual inspection. Most of the time, if a drill bit looks good, and I know that you might not have a lot of experience looking at drill bits, but if it looks like everything is uniform, there's a good chance that when you check it, it's probably going to be pretty close. So the first thing is you grab one, look at it, hey, this looks like the person might have had a good idea what they're doing. I'll hold it up to the sharpening gauge. I will make a note mentally where the tip is pointing on the gauge, which I can see this one's pointing at about the 8th division, and then I immediately spin the drill bit to the opposite side and I check that side as well. So that drill bit, as you just saw from the close-ups there, it's in pretty decent shape. Now, up to this point, all I've discussed is the correct angle and keeping the tip center. But I also think it's the appropriate time to start to talk about the relief angle right here. So from the cutting edge, right here, the relief angle is what's running down at that about 10 degrees, 8 to 12 degrees, 10 degrees. It just has to be going down away from the actual cutting edge itself. Now, if you don't have any relief angle, then the cutting edge is not going to be what makes contact with the workpiece. It's going to be the back support material that's going to touch, and if that's the case, you're not going to be removing any metal, because how can you cut if the cutting edge isn't touching? So the relief angle is going to be very important. The handout that you've been given has references to this relief angle, so you'll have a little more instruction than just what you're seeing on this video. But if I have a drill bit that's in pretty good shape, I actually like to take a black Sharpie, especially with someone that's new, and I like to color all of the previously ground cutting edges. Now what that's going to do is it's going to tell me every piece of the tip of this drill bit that makes contact with the grinding wheel. And if I grind or make a pass across the cutting surface and I see a large section of the black paint still present, then I know that I have to stop and think to myself, what correction would I need to make in order to have the next pass include that area that did not make contact with the grinding wheel? Because if you're starting with a more or less good tip, then it only stands to reason that you want to make all of the surface have contact with the wheel equally, and that's how you're going to maintain the good, correct tip. So, how do we hold the drill bit? Now, I'm a right-handed person, and I've seen right-handed people and left-handed people grind successfully with this method. So, even if it feels weird, I want you to follow these instructions. You're going to hold the shank of the drill bit, that's this section that does not have the flutes, in your left hand, and you're going to make the cutting edges level with the floor. Or sometimes I'll say to students, have them be level or parallel with the top of your thumb. The main thing is, you will not have a good result if your drill bit were to have the cutting edges going vertical. So horizontal cutting edges is where we want to start, and our left hand is going to be holding it's going to be using most of the holding force. Our right hand will be very safely resting on our tool rest, and then the drill bit will be set on top of them. Now some people like to go with just one finger on the tool rest. Myself, I've always just done with 2 fingers. You'll kind of figure out what's going to fit your body mechanics the best. And then the next thing we need to look at is, where should the tip of this drill bit be pointing? The worst thing you can do is come up here and have the drill bit pointing down at the floor. If that's the case, you're going to be grinding the cutting edge, or mainly this relief angle. It's going to be starting off going uphill instead of all downhill. So what we want to make sure we're doing is pointing above the center line of the grinding wheels. Now I don't want you to be way up here high like this, but somewhere slightly above the center line, or depending on the height of your guard, if it's kind of parallel to the floor, that would work. Now the next thing is, when I actually grind, I'm going to be lightly pushing in with my grinding wheel as I lower my left hand. So I'm pushing in as I drop the heel down. What I do not do is rotate or spin the drill at all. That's not required, and it's likely to cause you a whole bunch of trouble. So I'm just going in and I'm dropping. Now, I would come in, and when I first make contact, if the reading that I got with my sharpening gauge showed that the angle was good, and I want to maintain that angle, then I want the entire cutting edge to make contact with the wheel evenly. I don't want to touch the tip first and have a big gap on the outside, or touch on the outside and have a big gap to the tip. Because remember, that sharpening gauge was measuring the correct angle. So if the angle was good, I want to touch the wheel and have it be even all the way across. Now one thing I can do here in this environment is I can take my sharpening gauge, and when the grinder is not running, I can rest it against the tool rest, and I can make myself a little reference line. That line is going to help me orientate the drill, in addition to what I just talked about with making sure the entire cutting edge touches evenly across the wheel surface. But it is nice to have a line that you're keeping the drill itself in line with. So with all that said, I'm going to go ahead and check this grinder, because I checked the other one before. I don't see any visible damage. My guards, the gap is acceptable. So now I'm going to step off to the side and I'm going to turn on the power. After I do that, I'm going to have my face shield down, and I'm just going to let you watch me take a couple passes across the grinding surface. Now I'm going to get the camera a little bit closer so you can see what's going on. Now, I just took one quick pass and then I went ahead and I shut the grinder off because I want to show you exactly what I was talking about with, did my grinding wheel make contact with the entire cutting surface that I had just approved as being acceptable. So when I look here, I can see that I pretty much removed all of the black ink except for a small little section of it right here, which I'm very, very happy and content with, because this drill bit might have a little bit of an excessive relief angle. So after your first pass, take a quick peek down and see where you are and are not removing material. If it looks like this, then go ahead and continue grinding. All right, now that we have a good sharpened drill bit and we're very happy with the accuracy level that we were able to achieve with the sharpening gauge, we're going to go ahead and drill about a 1/4 inch or 3/8 into a piece of mild steel, and then we're going to measure the hole diameter and compare that to the drill diameter. Now again, we're just beginning and we're going to be happy with whatever we get as long as it cuts, and then from there we can start to improve upon the accuracy. But a cutting tool is the first goal. Next is an accurate cutting tool. Usually those two happen pretty much simultaneously because, like I mentioned over at the grinder, if a drill bit looks bad, it probably is, and if it looks like it's good, there's a good chance that it's likely to work. So let's go ahead and see what we get here. Now, when I take my drill bit and I'm going to load it into a drill chuck, if the drill chuck is too far closed or too far open, I want to make the adjustments by quickly spinning the adjustment collar with my hand. So right now it's closed, so I know I would need to open it up until the drill bit will slide in, and then I want to load the drill bit up to where the jaws are close to the beginning of the flutes. It doesn't do me any good to shove a drill bit any deeper into the chuck, and it's a very bad thing to be holding onto the flutes. Now, I ran it down, it's only hand tight. Next thing we're going to talk about is our chuck wrench. At no point do we ever engage the chuck wrench in the chuck and then leave it, because if it's hanging there like that, if the drill were to be turned on, it could either fly out and hit you, or it could get itself bound and be spinning around, and then that's just one more object that could grab onto a piece of clothing and then start to wrap you around the spindle. So we never let go of the chuck wrenches. I don't care if it's a drill chuck or a lathe chuck. We always keep them in our hand, make our adjustment, remove them, and then store them in whatever the proper location is at that piece of equipment. Now, when I actually go to tighten this chuck, what I'm going to do is I'm going to keep my wrist in a straight line, find a hole that lines up, and then now I can rotate my wrist downwards, and I can apply a great deal of force like that. I'm a lot stronger like this than I am like this. So whenever I'm tightening or loosening, I'm trying to either pivot down or pry back with my wrist. So the correct RPM for this drill bit diameter is approximately 800 RPMs. I'm going to go at a slightly lower speed, and when I bring down the spindle, I'm going to come and gently touch the drill bit tip while it's rotating to the top of the part, and then I'm probably going to use two hands to increase the downward force. What I want to see is chip formation. If I'm not pulling hard enough and feeding down into the workpiece, what I'm going to be doing is wearing out the tool and building up heat. Now, if I pull with what I consider a great amount of force and I don't see any chips being formed, then I'm going to go ahead and back away, stop the spindle, and take the drill bit out, being cautious on how long I rubbed. I could have built up some heat in the tip, but I'm going to take it out and then inspect it again and figure out exactly why it wasn't cutting. Sometimes the most common reason for that is you got the spindle going in reverse. So you will train your eye to be able to spot a spindle that's turning the correct direction. Alright, let's see how we did here. This is the drill bit that I just drilled the hole with, and it was a 29/64 drill bit, so it measures 453.453. That's the nominal size. And our hole size, about 459, 460. So I would like to see a slightly more accurate hole, but that's not that bad. And if I inspect the actual finish, it's not a terrible finish. You can tell I did deburr the hole before I brought it in here to the inspection table. So yeah, the drill did not give us chips going up both flutes, but it did an acceptable job. So let's look at some other drill bits. This drill bit right here, if we take a look at it, it probably has a little bit excessive clearance relief angle, and you know, this side here, that's the one that I actually ground, that where I showed you that at the grinder where there were still some of the mark remaining. So I was kind of trying to get away from that. Now what's happening when a drill bit has excessive relief angle is the operator is going up the wheel too far. But if we check the angle with the drill gauge here, it was a pretty good match on the angle, and from side to side, relatively centered. So not a bad job. And then the chisel edge there, in relation to the cutting edges, about 45 degrees. That's not quite 45, but it's not that bad. Here's a drill bit where I intentionally ground it to have a negative clearance angle. So you see, instead of, use something besides my finger, the cutting edge is here, so the clearance should be running down like this, where this one's basically neutral or even slightly uphill. Now what that would do would be when the drill bit made contact with the work, it would touch here and not here. And remember, that's the cutting edge. So if you make contact back here, nothing happens. All you do is build heat. In this side here, I got a little bit more of a negative clearance angle. So this would be from pointing too low, kind of pointing the drill bit at the floor before you start grinding, and then also not grinding up the wheel. So if you grind up the wheel far enough, you will get a clearance. Now in the event that you have excessive clearance like this, so again, looking at the cutting edge, then it's going downhill at a much steeper than 8 to 12 degrees. You're running up the grinding wheel too much. Now, you could inspect this, and you could see that it's possible to have excessive clearance and still have a drill that has a centered point with the correct included angle. Same with this one here with the bad negative. You can inspect this and think, hey, I should be good. My tip is centered. My angles are good, but my cutting edges, they're not touching, so it's not going to work. So just remember, this takes a little while to get used to, and practice makes perfect.